So,
welcome, Dr. Kaiser. Dr. Jochen Kaiser is head of visionary plane concept in the Bauhaus Luftfahrt EV. Just as many others, he studied aviation and aeronautics at the Technical University of Darmstadt, and then he worked 15 years for Airbus for cockpit development, and later on in the field of unmanned aircrafts, electrical flying and autonomous flying. For 7 years he has worked with Bauhaus Luftfahrt, head of division new aircraft concepts and drives. And we heard it this morning, many new engines are looked at, and with that there are new possibilities. You don't really know in what direction it goes, and there are differences between the sizes and the uses of aircraft. You will show that. You will first show what options we have and what possibilities they have for different uses and applications. And we heard about the shaft holes. We heard about that this morning. Maybe there is an answer with the new aircraft architecture. And we had another question that was entered in Slido, whether decarbonization versus noise reduction is something that you can solve. Maybe that's an important question for the future anyways, and maybe you have got an answer. Let's see whether I can give an answer. Thank you for the introduction. Welcome. The first reflective reaction from my side when the request came to talk on aircraft noise and new concepts, just don't do it, ignore it, because with the long-term research, it plays a minor role only, the concepts that we are dealing with at the moment. And then we sat together in the team of Bauhaus and just considered whether we have anything in that direction. We looked into technologies, and we also asked where is potential for noise prevention or noise reduction, or where could we have even more noise. And the first and foremost concept that I found was from the colleagues from the Foundation Hub. In the past few weeks, they looked into the Gartner hype cycle, the technologies and the different stages and where they are. And there were many things that we are also dealing with, but they reflect also on what might happen with respect to noise. Many things have been mentioned: sustainable aviation, fuels, hydrogen, and that's emission avoidance and reduction rather. It has little to do with noise directly. Autonomous flights, that only makes the cockpit more quiet because there are fewer pilots, but not necessarily on the ground. There is a bit of potential with electrical flying. We are far away from that. To have that in aviation, space travel, I leave that out. Another subject that is found there on the hype cycle is eVTOL, the air taxis. Definitely that's not a source of noise that we can compare with what we see at the airports, and they will affect a different area, but it's a new type of noise that we are facing, and we have to find out whether that's acceptable for inner cities. But it has nothing to do with our subject today. Then I found some other things that really stroke me. Airships. In terms of noise, definitely nice. If you have ever seen an airship, very quiet, but for transportation, it doesn't play a role. And also here it's regarded obsolete. Another subject that has come up is supersonic flight. I was happy to see here obsolete, because for quite some time we have been of the opinion that both from the energy point of view, energy consumption and emissions, it doesn't make sense to really deal with that. And for noise reasons either. If you've heard the Concorde when starting, for inhabitants, that really was no fun. So that's the rough framework of what we do in long-term research. Just to give you an idea where I come from, Bauhaus Luftfahrt, we are a very small research institution by the federal state of Bavaria and some industrial companies. 17 years ago we were founded. We are 50 people only, and we shall have a look at technologies far away for the future for aviation. And Bauhaus Luftfahrt says it. Bauhaus, we work interdisciplinary. We are not only engineers, I am an engineer, but we also have people from natural sciences, from the economy and social sciences as well. So having a look at aviation from all different angles. If I now look and see what we are doing at the moment, well, we have projects dealing with technologies and trends. These are our recent research fields. And here you find little noise only. Mainly it has to do with emission prevention and new drive concepts. That's what we should say here. Where do we have areas dealing with new aircrafts in connection with noise? We have the area of the small planes, commuter aircrafts in the past. Today we call it regional air mobility. It's a very small area and it's declining, although more and more smaller companies are working on it. But that would be an area where relatively quickly we could switch to electrical systems, and that's the goal, but it's extremely small compared to the total air traffic, so that wouldn't improve the situation. There's one other area where a lot of things are happening. Fuel burn is important, and here it's short, medium range, A320, etc. Here a lot is happening, also in terms of technologies. Here we can do something, and maybe we can think of batteries and electrical drives. We see that. And then one other area, maybe which wouldn't affect most passengers of fuel reduction, that's long haul. Here we can't really change to trains or other traffic means of transport, so we'll also need that in the future. Then let's have a closer look at technologies, the drive systems, propulsion systems. We deal with radically new propulsion systems for the engine as such. Here we've heard a lot already today what is happening here in order to reduce noise. Then integration of propulsion. Maybe we can do a bit here. The shielding, that was mentioned several times before, how I can include that in the concept development right from the beginning. Hydrogen has little to do with noise at first glance, but if I incorporate concepts like fuel cells, I have a stronger electrification and maybe reduce noise as a result. And this is happening in hybrid systems and partial electrification. Now, a little spoiler before I show you the next picture. We also deal with projects and concepts that will never ever be implemented that way, just to see what the consequences would be if we were to apply it. In terms of noise, what you see here is definitely not what most of you want to see. There was the question whether travel times could be reduced within Europe. That's a goal of the European Union, to 4 hours door-to-door travel times. And then people came from a neighboring university saying, if you take a closer look at the urban landscape here in many cities globally, there would be place for an airport. And a cross railway platform is in the city. So having said that, having looked at the project, how would an aircraft in the inner city look like? In terms of principle, it would work, but no one would build that. And it became clear very quickly, we need a completely new aircraft. It wouldn't work with the existing planes in terms of safety, but also in terms of noise, it wouldn't work. So that's where we looked into it, what would be possible here. Many things have been mentioned already today. I need not talk about that. Shielding, landing gears, fairings, etc. And you can make planes quieter if it flies slower. In comparison to the A320 Neo, here we could do something more with smaller and lighter vehicles, or planes rather. And the same also with the approach angles. The 12-degree angle was mentioned. We wouldn't do that, but 5 degrees would do something, would change it. we consider this also with respect to the technologies, that you could use them also for other projects, and therefore it's interesting for us, even if such an airport will never be built that way. A different subject that is mentioned in connection with noise is electrical flying, electric aircraft. Bauhaus Luftfahrt very early dealt with the idea whether you could have an aircraft larger than A320 and electrify it. We had a project on that and even had a first draft. It all would work out, with the exception of one subject, the battery. You would need batteries if you really wanted to fly it. Everything that's in the cargo space would be batteries then. And even with an energy density that we don't see for the time being in terms of the potential in the periodic system, we wouldn't be able to see that. So that will be difficult. We just wanted to know how far you would have to go. But what really would have an influence on noise would be the propulsion. The core propulsion doesn't produce most noise, but with an electrical drive, maybe you could use variable pitch blades and other things and optimize the noise situation. So that would be possible, but nevertheless, we miss the battery, the right battery for that. Then something else. If I have a look at today's planes, what else do we have in the pipeline? We want to improve efficiency as far as possible. A catchword that you hear often among researchers is the 50% aircraft. Today, aircraft with today's technology, 50% more efficient. Is that possible? And that also wouldn't have an impact on noise. First are the propulsion systems, so that I reduce the fuselage resistance. If I have a different wing, ultra-efficient wing, how much noise is created with the wing? So with a better wing you can achieve something. Hydrogen, I need not talk about that, but electrical drives would have an impact on noise. And then everything around the fuel cell. Today, I have power units and a little gas turbine which also produces noise. If I use a fuel cell run by hydrogen, I could do that. Apart from the fans, that's really silent. I saw the first test tracks in Ottobrunn with Airbus. They're extremely silent. It feels good. And then, of course, the engine has to become better and better. That's an old example. I'll show you something else. With our partner companies, I just looked around. With the MTU, they develop a water-enhanced turbofan engine at the moment. In principal terms, it's already known with gas turbines. They become more efficient if I inject water before combustion. On the ground it works well. In the air we had it with the 474. There was a water tank for starting so that there could be higher load on the engine. Here the idea is that I can inject water throughout the flight and have a more efficient engine consumption and reduce fuel consumption. But where does the water come from? The idea was you condense it directly from the exhaust flow, and you try to integrate that into one engine nacelle. From a noise point of view, I looked at that. I didn't discuss it with the MTU colleagues. I didn't dare to do so. But from a noise point of view, you have a very long and relatively massive nacelle. And it's more appropriate also to reduce and absorb noise. And the same also the core engine. It wouldn't produce a direct primary stream. Here it goes completely through the condensers in several loops through the nacelle. So it's reduced a lot, but it wouldn't produce any thrust any longer. You have to consider that. So we discussed that concept for a long time. We didn't develop it. We were only allowed to calculate everything. So we said you can't get 30% efficiency gain immediately, but there is something behind. It might work, but it's a long way to go till such systems will be offered. It's an interesting approach, and also in terms of noise, it could have a good effect. This picture was shown already, open fan, open rotor. In terms of efficiencies, it's highly interesting, also for us. We need to admit that. So we need to see whether we can do additional savings. How you can install it in a noise-optimized design, you have to see whether you can use shielding or improve the propeller design in such a way that noise is reduced. I mean, that would be the most interesting part of it. Basically, an open propeller is not a noise problem if it's designed properly and used in the right speed range. More and more, and that's a concept that students developed, and therefore it looks a bit rudimentary. But what you see easily is there are more and more approaches to fly more slowly, and then such engines or propulsions are much better for noise. And this was mentioned several times before, the blended wing body. Two different concepts. The Maverick from Airbus is seen more often, or the Flying V of the Technical University of Delft. You can see that the engine is on the fuselage, which is good for noise radiation. We won't see that aircraft very quickly. That's what we think, because the classical arrangement for airlines and for operations has a lot of advantages. And the development of such planes would take very long till we can use them for everyday flights. And then something else comes in addition, and that's always a big obstacle. A manufacturer basically wants to have an aircraft that can be stretched or shortened, or develop a whole family of aircrafts. And with that concept, that's not possible at all. If you build the aircraft in one size and you want to have one 10% larger, like the A320 or 21, you have to build a new aircraft. And therefore, I don't believe that such concepts will come in the next 20, 30 years for classical passenger transportation. For specific purposes, transportation, cargo, military, yes, maybe, but also there, savings that we have seen in our concept studies compared to classical configurations wouldn't be very big. If I do a good job, that is, and this is rather about hydrogen. Here, if I design a different wing, and that's happened here, I have a dry wing using hydrogen. You cannot have the fuel tank here. You have to put it into the airframe, and then you can have the shift. The wings are much more aerodynamical, but the weight in the wing, of course, is an important point, but I can have very long, slender, and more efficient wings. As I mentioned before, with hydrogen, the APU can be replaced by fuel cells, and also as the wing wouldn't house fuel any longer, I can have different designs, but less vortex and turbulences. I can use the space for the propulsions that are outside, and we heard that a lot of noise is generated by components outside the aircraft, outside the airframe. So you can integrate them into the wings. So the aerodynamics of the wing can be influenced by separation, suction, etc. So all that might have an impact if I can involve that right from the beginning in my concept making. So that's the main task also for the developers. Tri-wing, that's dry wing that really offers a lot of potential. So I talked a lot about technologies. What we also looked into when we looked into long haul, how people fly at the moment, and we have found, I mean, first it's about fuel reduction, and I mean, maybe you should not have flown at all in the first place, and that will also have an impact on noise. And then we looked into long distance and long haul, and we looked how flights are distributed. 1 stop, 3 stop, flights and how many detours people take. And we have found that nowadays, because of the airline system, you make a lot of detours and you have more flights than you actually needed for the transportation volume, especially with long haul. Most flights are indirect. You have certain hubs where you change flights. First you have a short distance flight and then you have the long distance flight, and maybe you change again to have a shorter flight in the United States maybe. And it's not that direct connections wouldn't be there, but today's systems and the pricing often lead to the situation that people buy multi-stop flights. Okay, it has changed a bit in the past 2 to 3 years. The study was carried out shortly before Corona. Now you have not that large aircrafts any longer, more smaller ones with direct connections that goes in the right direction. But nevertheless, many, for cost reasons, would use the other flights with more stops. And that's really where we can do something, where we can really achieve the goal more quickly. Less flights, fewer flights is less noise. And then we had a discussion with airlines and with our partner Airbus, because it would reduce the sales of aircrafts if you did it that way. But on the contrary, there are other possibilities out there that aircrafts can be used for different purposes, and that would offer more advantages, but that would go too far for today. Here, my little summary. For the smaller aircrafts in the future, here you might see electrical propulsion, fuel cells that offer the power. Here you need to make sure that the noise radiation of the propeller is optimized. That's the challenge. But I see big potential in that for regional flights. Medium short range, here we looked into it as well. We said if we did that with hydrogen, then you would have hybrid systems. One gas turbine, maybe, and here we get problems if we say single turbine. The registration authorities don't like it, but if you have a hybrid powered system and make the energy available for a starting maneuver, you can do that with one gas turbine in the rear, shielded a lot. Then maybe a big part of the noise is encapsulated and reduced. With the long haul, long range, here today's aircrafts are not that bad in terms of basic concept. Here we have to increase efficiencies, minus 50% aircraft, put everything there in terms of technology that is available. There's a meeting in Bremen tomorrow with the colleagues of Airbus and research to make progress here. In terms of noise, it has little effect, but becomes cleaner and better. And what is considered here as well is the total organization. That is, can I reduce air traffic as such, reduce number of flights, and thus create motivation for a more responsible aviation in general. Okay, that's it. Thank you very much. And I'm available for questions. Thank you, Dr. Kaiser, for your presentation. You had a very attentive audience. I've observed that. These are all very interesting subjects if you imagine how flying will be in the future. There is a concrete question for you. How do you see the box wing concept? I Googled it. You know what it means. There are some research projects that have just started. Box wing means that I have a double-decker configuration where the wings are connected. It's difficult from a structural point of view. For smaller regional aircraft, you could do that. There are other ideas with distributed electric propulsion. in order to use the wings also for short distance flight. That's okay for special purpose aircrafts, but for larger ones, A320 upward, we don't see that. So the classical concept with one wing without any disturbance or interruption, that makes more sense. Okay, thank you. We don't have concrete questions for you, but stay here on stage because we would like to discuss it now together, this subject of the future, and we are happy to take your questions. You can enter your questions in between or ask for the floor, and in the meantime, Dr. Richter, Dr. Stoker, and Mr. Moyle can come up on stage. I get my headsets and become equipped. So make sure that you are also well equipped, and now we need the interpretation from English into German and German into English.